Mann, Whitney, U. So this Mann, Whitney, U is the non-parametric analog of the independent sample t-test. Yes. So now the research question would be the same in case of a Mann, Whitney, U also, because here also if you see the research question, the same research question is written here, which you have seen in the independent sample t-test, because the question is different. The question is same. The only difference is that normality, and we have seen that if there are many outliers and if the data is not normally distributed, then we apply this test. So this is again the same, like if I have planned to compare the mean of my variable across the two categories, but the variable of interest was not normally distributed when I have checked for it across the two category of nominal variable. This is again the same. So these are some of the example of the data which shows that normally it is not distributed, like median duration of hospital stay. It is very, very widely, there is a high range of this hospital stay. One person can stay for 1 month, 3 months. One person can stay from 1 day or 2 days. So generally for duration of stay, we use this median duration of stay because mean will be then not the true representative. Similarly, the income level of general physician and general surgeon, if you compare them, there is a huge difference between and it is normally, it doesn't follow a normal distribution. So this is again an example of research question. By just seeing the variable, you can have a rough guess that these should not be compared because that will not be normally distributed. And again, the CRP level, if you are comparing the CRP level of severe and mild COVID, definitely it is not going to follow the normal distribution across the two categories because it varies widely. So there are some example of a research question also, but again, we cannot say by just seeing the research question, and you should always check it objectively, the normality and the outlier, concept of outlier. So here I know that the variable of interest, it doesn't follow normal distribution. So I have beforehand, I have planned that I'll compare the median, but again, I have planned, but again, I need to check also seeing the distribution of the data. So what have you observed in all these three cases? That this is a scale variable in all the three research questions, and I want to compare it with the two nominal category of the variable, like we have seen in the student t-test. So the appropriate statistical test would be a test which will check the difference of median value. Here we will use the term median. So median value of a scale variable across a binomial variable. So you are right. The correct option is the Mann-Whitney U test. So now Mann-Whitney U test, it has got a certain characteristics. What are those characteristics? So it is a rank-based non-parametric test, which is also known as the Wilcoxon-Mann-Whitney test. Here there is one dependent variable, which is a continuous variable, and one independent variable, which has got two categories. This is same as independent sample t-test, and independence of observation and the distribution. Now these assumptions are same as that of an independent sample t-test. But here you will see the assumption 5. Here we say that distribution of score for both the group of independent variable have the same shape. We have learned about the shape in the normality, about the symmetry, about the left skew or right skew. That means it tells you that both should be towards the right or both should be towards the left. If there is a mismatch, also there is a way to analyze that, and we'll see how to do that. So like this is one example where in example 1, BMI, you can see it is of the same shape. It is a skew, both male and female, but the shape is same. But if you see this, there is a different shape. Both these are having a different shape. So the hypothesis, if I see, the null hypothesis is this, that the median of the two groups are equal, whereas the alternative hypothesis is this, that the median of the two groups are not equal. So this is the null and alternate hypothesis in case of a Mann-Whitney U test. Now, again, the normality testing. This is the command which I have shown you. So if I go to back to this all commands which we have shown you in the sessions, that has been pasted in your PowerPoint also. So you may refer it when you need, because right now you're not going to perform all the operations or all the statistical analysis. So keep them as a reference. And when you encounter some data set or in a research question or any publication where you need to put all these tests, you can refer these commands and you can again, and do the analysis on your own. So coming back to the question, because this was the basic theory of Mann-Whitney U. And if I go to the question of this Mann-Whitney U, so the question is, I want to study whether there is any difference in the mean SGOT level of patients who have the first MI episode and compared to those who have the recurrent MI. So I have to compare both the SGOT and LDH of first order MI and the second order MI. So I will go to my demo data sheet. This is the demo data sheet. I'll go to the variable. You can see the variables. This is ID, age, gender, race, socioeconomic status. So these are the values are there for the race, for the gender, for the socioeconomic status, and for the MI order. And then these values are SBP, DBP, total protein, SGOT, and LDH. They are the continuous variables, so they have been named as scale variable. The role is none. You can again change here the SES, the ordinal, and you can change this MI. No, the MI will not be ordinal. That is nominal is okay. So only the SES will be ordinal. So this is the data description of the data. And if I go to the data view, then you can see the data. So before I go for this SGOT and LDH, I need to check for the normality. So what I will go to the analyze, descriptive, explore. I'll take this plots. I'll move this SGOT, pressing the shift button, SGOT and LDH to the dependent list. And I have to check it with the order of MI. So MI, I'll move here in the factor list. Then I'll go to the plot. I uncheck this. I check this. Continue. Press OK. So if you press OK, you can see here the case processing summary where you can see the value, how many of them was having the first and the second order MI. Few cases were missing here. You can see 4 cases. That is also there. Total number is the 189. So that missing case you can see, and then you can see the value of this significant or not. So you can see here it is significant, whether this LDH is non-significant. So, but we will not see the value of Shapiro-Wilk. We'll see the QQ plot. So you can see it is deviant. Can you see? This is not across the diagonal line. And if you see the QQ plot of SGOT across the second order MI, then also it is not across the diagonal line. Then you come to this box plot. So can you see there are huge numbers of outlier in both the cases, in case of a first order MI and a recurrent order MI. So these many outliers, and if these many outliers are there and it is also not following normal distribution, then we need to apply the non-parametric test. If you go down and if you see the LDH also, then you can see here LDH, you can say that it is roughly it is on the across the diagonal line, the first order. And then if you see the recurrent, this was a recurrent order, sorry. If you see the first order, this was for the first order, then this is not normally distributed. So what we have discussed, that even if across one group, it is not normally distributed. If you see this, it seems to be normally distributed. But if one is not normally distributed, then also we will apply non-parametric test, and you can see the outlier. So you can see the number of outlier in the first is very high. In the second, there is only one outlier. And I have decided that I'll go for a non-parametric test. So now what will I do? Just see its command. So for this, I need to go to the analyze. Now analyze this, you have to go to the non-parametric. Remember yesterday we did that goodness of fit through this command only. We went to that and we went for this legacy dialog where I have clicked that chi-square for the goodness of fit. Here, because I have to do a non-parametric Mann Whitney U and it is the independent sample. So I'll click this independent sample. The first one will come with the objective. Don't have to do anything. Go and click this fields. Now this is the test field. So you need to move your SGOT and total protein to this test field. The size of the test field is large, you can see here. And also you can see the type of variable. This sign is for the scale variable and this sign is for the ordinal variable. So this is the variable which I have moved here. And in grouping variable, because it is in my MI order, so I have moved this to here in MI order. Now what I'll do, I'll go to the setting. In the setting, you go to the customize test, automatically choose test. No, I have pressed this option. Here you will see there is an option of Mann Whitney U. Here is the compare distribution. There are various options, Kruskal-Wallis, Jonke, Terpstra, Kolmogorov, but I am not using any of these tests. The choice of test which I'll use, that is the Mann Whitney U for 2 sample. So I've clicked this and then I will press this run. So if you press this run, you have this, both the values of the null hypothesis, independent, this alternate hypothesis and decision. So the significant value is 0.019. That means it is significant. And this LDH, it is not significant. So the null hypothesis is rejected and alternate hypothesis is rejected. So it will give you only one output. Now you need to double click this table. Then it will lead you to a model viewer. So this is the model viewer where it will show you the distribution of the 2 variable. And you can see here the sample statistics. So just focus for a few minutes here. Here you can see the N60 and N33. And this is the distribution of the SGOT across first order MI. This is the distribution of SGOT across recurrent order MI. So you can see here that usually they are almost of the similar nature. And this is the mean rank. So mean rank, you know what this SPSS does? It assigns the values in form of a rank. Like if there is a first value of SGOT is 200, the second value is 280, the third value is 300. So it will assign these values as an ordered rank as 1, 2, and 3. So this rank gives you that ranking. It is not the median, right? So for median, we will perform another command. So from this, what you have to take, this is the 193 sample. This is the test statistics of Mann Whitney U. And this is the standard error. You have to report the standard error. This standard test statistics, that is the Z statistics, and you have to report the P value. So from this, you will take 3 values. You will take this Mann Whitney U test statistics. This is the same. You will report this as the Z statistics, and you will report this P value. Is it clear? to all of you up till this point. This is just the histogram which you are seeing it. This is just the histogram, a comparative histogram of both the means the distribution of variable across both the group. So this is the histogram. This is the histogram of the SGOT in the first order MI, and this is the histogram of SGOT in the second order MI. Okay. If you want to know about the LDH, now click the LDH, and then the graph of LDH will appear with the Mann Whitney U statistics, standardized Z statistics, and p-value. But this Mann Whitney U doesn't give you the value of median and interquartile range. So for that, what I need to do, I need to go and check another and do another command. So for that, I'll go to this Mann Whitney U, go to the analyze, go to this mean. In descriptives also we have seen, if you press this explore, but that doesn't give you the overall mean across the, let me check. Analyze, you go to the compare means. In explore, I have to check the value of SGOT and LDH across this MI order. So I checked for the plot. Now I have to check for the statistics. So go to the statistics. It is already there. I don't want percentile and all. So I have pressed OK. This option, I don't have to do anything. Press this OK. And then you will have this median value. So you can take the median of SGOT. This is the median 49 with interquartile range. So what value I have to take from here? Median is 49 and interquartile range is 47. Similarly, if I go down, so in recurrent also, median this is the median 59 and this is the interquartile IQRS 48. So from the explore statistics option, you can have the median across these two groups, which you will not get when you do a Mann Whitney U test. So Mann Whitney U test gives you the mean rank. It doesn't give you the median value. So for the median value, you need to use the statistics option of explore and then take the median across the two groups with the interquartile range. Is it clear to all of you? Then I'll go for the analysis and interpretation and how to enter the result in the table. No. In IQR, we don't write two values. IQR is the difference between the 75th and 25th. So that's why we don't write. If you want to write the IQR, then you can click that. I'll just show you. If you want to, so what you go to the analyze. I didn't click that. So you know by your descriptive. So if you want that range, you can click this percentile, continue. Okay. You will have this percentile. You have seen that in the descriptive option, where this is the 25th percentile and this is the 75th percentile. The difference of these two values will give the interquartile range 76 minus 29.50. But if you want to give it like 25th and 75th, then it is, you can take it from there. So Priyanka is writing if LDH is normally distributed and SGOT is not, then also median to be calculated for both. No, if LDH is normally distributed, but in this case, you will see that the distribution is different across two groups. It is normally distributed across the recurrent, but is not normally distributed across the first order MI. In that case, if across the one order, if it is not normally distributed, you can take the non-parametric median for both. Or else, many people, they recommend that even if there is a dissimilarity, you may go ahead with the independent sample t-test. That we discussed in the independent sample t-test, because independent sample t-test is a robust test. So you may go ahead with a slight difference in normality. So if one group is not normal and the other group is not normal, and if the sample is large, then you can apply independent sample t-test also. Okay. Okay. Thank you. So if it is clear, is the command clear to all of you? How to calculate the median? So if it is clear, then I'll go with this interpretation and how to write it in the table. So this was the output. So you can see I have written the median and the recurrent first in this order, and the mean rank also. So you can write both the things, median and mean rank, and then you can write the interpretation. I have written the Mann Whitney U value, the Z value, which I have shown here, the Z statistics. If you go up and see the graph, this was the graph. If you double click this, you will have a model viewer. You can see here that the Z statistics is this. So you can report this also. And then you can write your interpretation. So I'll hide this and I will enlarge this. So now one of you can read this for me. Here I have not given the interquartile range. You can include that in the bracket. In the median, you may include the IQR. Like we write for the mean and SD. Similarly, you can include those values here. So one of you can read this. Anbarasu, I'll always ask your name.
I'll read. The values of SGOT was not distributed normally across MI order as tested by visual inspection of QQ plot. A Mann Whitney U test was run to determine if there were any differences in SGOT level between first order and recurrent MI cases. Distributions of SGOT levels for first order and recurrent MI cases was similar as assessed by visual inspection. The median SGOT for first order MI was 47.0 and recurrent MI was 9.5, was statistically significant. U is equal to 4831 and Z is equal to 2.34 and P value is 0.01.
Okay, so here you can write visual inspection of histogram because that was the visual inspection of histogram. And here you can write there were many outliers. That was not, that comment is not there. So there were you can write significant outlier.
Okay.
Significant number of outliers. Which was kept. Which was kept in the analysis. So is it clear to everyone? Similarly, I think we have shown it with one, this both SGOT. Similar concept will apply with the LDH. So if it is understood by all, I'll once again repeat the command for everyone. So we will test for normality. I'll go to the analyze, descriptive, explore. I'll use the option of plot for normality. Come to the plot, see the uncheck this stem and leaf, check this multi-plot, press the continue, see the see the box plot, see the QQ plot, comment on it. Then again, go to the analyze. Here you have go to the non-parametric option. It is a independent sample, t-test, so go to the independent sample. Independent sample, it will start with something like this. There are three things: objective, fields, and setting. In objective, you don't have to do anything, come to the field. In the field, you move this to the test field, and then in the grouping, you have to press the group like you did with the independent sample t-test. Then go to the setting. In the setting, you have to use a customized test. In the customized test, you have to press this Mann, Whitney, U for 2 sample, and then press this run button. And if you see the output, you will have only single this table hypothesis test summary. But when you this yellow and blue test, this shows that this is active now. So when you double click this, it will lead to a model viewer where you will be shown the test statistics and the histogram of both these two together, showing the mean rank of these two value, but it doesn't give you the median. So for the median, you need to go to the analyze and then go to the explore. Under the descriptive, go to the statistics. In the statistics, if you wish to know about the percentile, click that and then press continue. You will be presented with a table, this output of this sort, and then you can take the median and the interquartile range of this one, LDH and this thing. So you can use the median and IQR. If you wish to write the 50th, 25th percentile and that you can take from this place, 25th and 75th percentile. You should enter the result in the table and then write the interpretation. So is it clear to all of you up till this point?